Hello guys, welcome to Algorithms playlist. So today I'm explaining you the advantages of using a three-pointer approach. But before that, I want to explain you the brute force approach. So this is the nums2 array which has 6, 7, 8, 9, 10, 55 elements, and nums1 array which has like 1, 2, 4, 5 elements. After that, we have zeros in this. So here I've just calculated that length and m has like this and that, like length, which is like no need. I didn't use this, so I just put this in comment. And here I have used like just brute, like how do you merge second array, first array into second array, which has which can accommodate the space. So to understand this, you just apply for loop and you just append afterwards, and then you sort it and then you get it. But this made me think, if I want to optimize this approach, how do I do that rather than just putting this like that? So you use pointer. If you understood this and you are comfortable with the syntax in the Python, then you should be approaching pointer, if it even if it is hard at the first class. But this is definitely not hard when you take a fifth class or seventh class, right? So initialize this three pointers. So first you just initialize. How do you initialize? You initialize the pointers with the last elements of the each array. So p1 is the last element of the first array. Second array is a m minus 1, so this is the second array. And third is p equal to m plus n minus 1. So these are the code, the pointer initialization. Merging second array into first array starting from the end. So we are not using a sort approach here, and this is definitely very must, like this is the O1, like O1 time complex O1 type subspace complexity. But it has, this approach can take O1 and O of m plus 1, m plus n plus log of m plus n. So this approach has plus log m plus n. This is definitely more advanced approach because this is just O of m plus n. So this is definitely much more advanced approach which reduces the time complexity of the code. We How do we do that? We just initialize the pointer, and using pointer we can just point to the last element, and as we add this last element, merge the last element, after successful merge it just reduces the pointer number. So we are indicating the second last, then third last. So we are going from the backward and we are assigning to the forward. uh, so if you understood this, then you definitely understood this, that placing num2 of p2 at the current position. If 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 this is not greater, if they are equal or less, then definitely we are placing that array to the right. So this is, then we move backward here, right? So we should assign it that p2 minus minus 1. So this is again a moving backward, both moving backward. So moving the merge pointer backward, so move the merger pointer backward. So the pointer as a whole, like the merger pointer, this is merger, that this is the 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 pointer of the biggest array, that is m nums 1, that has 1 plus n index. So this was the approach. Thank you so much.